that you find there. If you don't have the packet with you, all you got to do is just write down the information from each spectrum and then go back, look at it on ELC, match your notes. But the main thing is to look at this and listen and understand the process here. All we're doing is looking for functional groups to start with. Primary amine has this multiple stretch signal. It's very wide, but not as wide as an OH would be. Okay, so we don't worry about an OH. That's evidence of nitrogen. When you have a primary amine, the other vibration that you have in the spectrum is an NH2 bend. And I do see that here. It's shorter and lower chemical shift than a carbonyl would be. A carbonyl would be much more absorbent and longer. This is a bend, so it's shorter and it's still pretty wide there. Good evidence that we've got nitrogen. Immediately I'm thinking odd molecular ion. Let's have a look and see if that's the case.
Okay, I got a video.
Sure enough here, oops, excuse me there, that's 58. 6, 7, 8, 9. So I almost picked 58 at 8.7%, but with only 3 or 4 carbons in this structure, so if we did 58 divided by 13, we'd get 4 and some change. 4 carbons can only give you a 4.4% isotope peak. 3.1 divided by 8.7 is 35%. That's too big to be an isotope peak. 59 is too big to be an isotope peak in this spectrum. Only 1.1% of carbon is carbon-13. With only 4 carbons, our odds of getting a carbon-13 are only 4.4% of the previous mass. So 4.4% of 8.7 is much less than 3. There. That's our second piece of evidence that 59 is the molecular ion. Our first piece is we see a clear NH2 in our IR. The nitrogen rule says for an odd number of nitrogens, look for an odd molecular ion. Does the first fragment, the base peak here, 44, make sense? So 59 minus 44 is M minus 15. That's a methyl. That makes sense. So I feel pretty good that I've got my molecular ion. The only problem is that's our only major fragment. Our only major fragment here is loss of methyl. With a nitrogen present, when we lose an alkyl group, that typically means alpha cleavage. Sigma is rarely dominant when there's a functional group present. So that's probably an alpha cleavage. If it were an inductive cleavage, it would leave us with a carbocation and the loss of a nitrogen-containing species. We don't see that here. So if we're trying to find the molecular formula, we've got to explain these two things. And so like we said, take 59, our molecular ion, divided by 13. We've already got some credit for labeling NH2 in the IR. We've already got some credit for the NH bend. We found the molecular ion, we've got some credit there. All right, so we're at that point. Now, we said 4 times 13 was 52. So we had C4, H4, and then our remainder was 7. C4H11N, does that make sense? Well, our degrees of unsaturation are 1 plus the number of carbons, plus the number of nitrogens over 2, minus the number of hydrogens and halogens over 2. That's 5 minus 5 is 0. So that does make sense. That is a physically possible molecular formula. Just has no pi bonds, no rings. At this point, I've got more points because I've gotten to a molecular formula. Yes?
Where did the 54 go? When you divided 59.
The nitrogen gets added.
When you divided 59 by 13.
And the hydrogens get subtracted.
52. He divided 59 by 13? Yeah, because it's two molecular atoms, and then that's 13 carbon plus
Oxygen. Oh, the nitrogen.
hydrogen.
Nitrogen,
So you
yes.
got 4, and then your hydrogens is 4
Good
plus
catch,
4.
good catch. So subtract the
And then
nitrogen.
you add your
He's really good at this.
What happened? I don't know. Did you get it wrong? If he's getting it wrong, how am I gonna get it right?
Nitrogen weighs 14.
Yeah, do you have it from 44? Like, why would you divide? 44 is your fragment peak, so that's not like all of the.
Which is a CH2. C3H9N.
Reduced degrees. Can you check that by adding the weight? Adding the molecular weight, which should equal 59? Why did he change it? Because the original one with the C4H11, he didn't account for the weight of the nitrogen, he just added it on.
Okay, so as we do with the all carbon hydrogen, C4H11. And then subtracting a CH2, or exchanging a CH2 with a nitrogen that we saw in the IR gives us C3H9.
And an oxygen is a CH4. I don't know.
4. Our final structure.
Yeah.
Propose isomers that match your IR and mass spec, or your molecular formula. Okay, all 3 of these match the molecular formula. Okay,
Wonderful.
which one gives us the right alpha cleavage? That would give us an M-29. This would give us an M-15. There is no beta side. Well, there is a hydrogen. That's why we get this M-1 right here. Or could get M-1. Okay? But look at the hydrogen. It's a secondary amine, not a primary amine. The only way to get only M-15 as the base peak is to have 2 propanamine. Okay? Partial credit for having the right amine, or having an amine, full credit for having the correct placement of the amine on the parent chain. So you can get, if you put this structure, you know, maybe we're pretty somewhere close to 13 to 15 points. If we get the alpha cleavage assignment, we get up to full credit here. Okay?
It is.
And then the secondary amine